March 15th, 1944, 28,000 feet above the German countryside. Hauptmann Klaus Weber squeezed the trigger of his Messerschmitt BF109 G6, watching his 20mm cannon shells streak toward the massive American fighter ahead. Direct hits. He saw the explosions bloom across the enemy's fuselage, wings, and engine cowling. In any rational universe, that aircraft should have been into flaming debris. What? Instead, the integrating Republic P-47 Thunderbolt continued flying straight and level. Its pilot apparently unaware that he had just absorbed enough punishment to destroy 3 Spitfires. Weber's wingman, Oberleutnant Friedrich Müller, had emptied his entire ammunition load into the same target. 260 rounds of mixed cannon and machine gun fire. The American fighter bore scorch marks and puncture holes across its massive frame, yet it flew on with the casual indifference of a transport aircraft on a training flight. As Weber watched in disbelief, the P-47's guns swiveled toward him, 8 synchronized Browning machine guns that would teach him why German pilots had begun calling these aircraft flying fortresses. What Weber couldn't have known was that he was witnessing the culmination of American industrial engineering philosophy. While German aircraft designers pursued lightweight interceptors optimized for agility and climb rate, Republic Aviation had created something fundamentally different. A fighter built around the concept that survivability and firepower mattered more than grace or elegance. The mathematics of aerial combat were being rewritten not by tactical brilliance, but by systematic over-engineering that would transform every assumption about what a fighter aircraft could endure. The story of how one aircraft became seemingly indestructible begins not with dramatic aerial battles, but with a quiet engineering decision made in a Farmingdale, New York factory in 1941. Alexander Kartveli, Republic Aviation's chief designer, faced a challenge that seemed impossible. The United States Army Air Corps wanted at altitudes where German fighter that could operate interceptors struggled, carry enough fuel for long-range missions, and survive the kind of punishment that destroyed conventional aircraft. Traditional fighter design said you couldn't have all 3. Kartveli decided to prove traditional design wrong. The solution required abandoning everything the aviation world thought it knew about fighter construction. Where other fighters used lightweight aluminum structures optimized for speed and maneuverability, the P-47 would be built like a flying tank. The fuselage incorporated armor plating that surrounded the pilot with steel barriers. 3/8-inch armor behind the pilot's seat, 1/2-inch bulletproof glass windscreen, armored plates protecting the engine and critical systems. This wasn't subtle protection. This was a fortress designed to keep flying after absorbing damage that would vaporize lighter aircraft. But armor was only part of the equation. The real revolution lay in the P-47's power plant and the engineering philosophy behind it. The Pratt & Whitney R2800 double wasp engine represented American industrial might at its peak. 18 cylinders arranged in 2 rows, producing 2,000 horsepower through supercharging systems that maintained sea-level performance at altitudes where the air was too thin for most engines to function. This wasn't just more powerful than German engines. It was fundamentally different in its approach to reliability and damage tolerance. German aircraft engines, masterpieces of precision engineering, operated with liquid cooling systems that required intact radiators and coolant lines to function. A single bullet through a coolant line meant engine failure within minutes. The P-47's radial engine had no such vulnerability. Air-cooled cylinders meant that individual cylinder hits rarely affected overall engine performance. Multiple cylinders could be completely destroyed, and the remaining ones would continue operating. German pilots discovered this reality through bitter experience as they watched P-47s fly home with engines that looked like Swiss cheese but somehow kept running. The firepower disparity proved even more devastating than the armor advantages. While German fighters typically carried limited ammunition for their cannon, perhaps 150 rounds per gun, the P-47 packed 3,400 rounds of 50 caliber ammunition across 8 synchronized machine guns. This wasn't just more bullets. It was a completely different approach to aerial gunnery that prioritized sustained fire over individual shot effectiveness. Where German pilots needed precise aim with limited ammunition, American pilots could maintain continuous fire for over 30 seconds, creating walls of lead that made evasion nearly impossible. The ammunition itself represented another level of American over-engineering. Each 50 caliber round weighed nearly twice as much as German rifle caliber bullets, carrying enough kinetic energy to punch through armor plating and structural elements that deflected lighter projectiles. The incendiary rounds burned at temperatures hot enough to ignite aluminum, magnesium, and fuel systems. Armor-piercing variants could penetrate tank armor at close range. When 8 such weapons fired simultaneously, they created a convergence pattern that German aircraft simply couldn't survive. Training American pilots to exploit these advantages required developing entirely new tactical doctrines. Traditional fighter combat emphasized turning fights where agility and pilot skill determined outcomes. The P-47's massive weight made it inferior in such engagements. Instead, American instructors taught boom and zoom tactics that leveraged the aircraft's strengths while avoiding its weaknesses. Climb to altitude where German fighters couldn't follow effectively. Dive at speeds that made interception impossible. Fire devastating bursts during high-speed passes. Zoom back to altitude before enemies could respond. These tactics horrified traditionalists who believed aerial combat should showcase pilot skill and aircraft grace. The P-47 approach seemed almost unsporting. Massive aircraft using overwhelming firepower and superior altitude performance to destroy enemies who couldn't effectively fight back. German aces, who had built their reputations on turning fights and close-quarters maneuvering, found themselves helpless against American fighters that refused to engage on traditional terms. The psychological impact on Luftwaffe pilots proved as significant as the physical destruction. German fighter doctrine had always emphasized individual pilot skill and aircraft performance. Superior training and better machines would defeat numerically superior but inferior opponents. The P-47 challenged this entire worldview. Here was an aircraft that could absorb punishment, that would destroy German fighters, deliver firepower that made evasion nearly impossible, and operate at altitudes where German interceptors struggled to reach. Worse still was the casual abundance these aircraft represented. While Germany struggled to replace losses and maintain adequate pilot training, Americans were producing P-47s faster than the Luftwaffe could shoot them down. Each loss was quickly replaced by factory-fresh aircraft with experienced crews. German pilots who survived encounters with Thunderbolts often discovered that shooting one down merely meant facing 2 more the next day. The industrial implications became clear as 1944 progressed. Republic Aviation's factories were producing completed fighters faster than traditional aircraft manufacturers could build prototypes. The Farmingdale plant alone completed 1 P-47 every hour during peak production periods. This wasn't just mass production. It was systematic demonstration that American industry could outproduce German manufacturing while maintaining quality standards that exceeded German precision engineering. As spring turned to summer in 1944, German pilots across Europe were learning hard lessons about American engineering philosophy. The graceful Messerschmitts and Focke-Wulfs that had dominated European skies since 1940 were encountering aircraft that seemed to violate every principle of fighter design. Too heavy to turn effectively, too large to hide, too slow to run from modern interceptors, yet somehow these ungainly machines were systematically destroying the Luftwaffe's most experienced pilots through sheer, overwhelming capability. The revolution in aerial warfare was just beginning. The transformation became undeniable during the massive air battles of summer 1944. Over the Normandy beaches, German pilots encountered something that shattered their understanding of aerial combat. Staffel after staffel of experienced Luftwaffe fighters would dive on formations of P-47s, confident that their superior maneuverability and proven tactics would carry the day. What followed defied everything they had learned about air-to-air combat. Oberleutnant Hans Dortenmann, leading a formation of 8 Focke-Wulf 190s against 12 Thunderbolts near Caen, should have been a textbook attack. Executed what? His fighters dove from the sun with perfect positioning, catching the Americans in a vulnerable climbing turn. The first pass should have scattered the formation and left burning wreckage falling toward the French countryside. Instead, Dortemann watched his cannon shells explode harmlessly across P-47 fuselages that absorbed the punishment and kept flying. The American response came with mechanical precision that German pilots had never experienced. Rather than breaking formation and engaging in individual dogfights, the Thunderbolts maintained their defensive circle while their combined firepower created overlapping fields of destruction. When Dortemann's wingman attempted a second attack run, he flew into a crossfire from 6 different P-47s. The concentrated .50 caliber streams didn't just hit the Focke-Wulf, they disintegrated it in mid-air, transforming 4,000 pounds of aircraft and pilot into expanding debris in less than 2 seconds. The mathematical reality of firepower concentration was becoming apparent to German survivors. A single P-47 could put 400 rounds per second into the air during sustained fire. A formation of 12 Thunderbolts generated nearly 5,000 rounds per second. No German formation could survive exposure to such concentrated firepower, yet German aircraft couldn't generate enough damage to seriously threaten the heavily armoured American fighters. Major Gerhard Barkhorn, one of Germany's highest-scoring aces with over 300 victories, mostly achieved on the Eastern Front, encountered P-47s during a transfer to the Western Front in July 1944. His combat report, recovered from Luftwaffe archives after the war, revealed the profound shock experienced by even elite German pilots. The American fighters absorbed our attacks without apparent damage while delivering counterattacks of unprecedented intensity. I observed direct cannon hits on enemy aircraft that continued normal flight operations. Their return fire was so concentrated that evasive maneuvers became impossible once they achieved firing position. The P-47's durability wasn't accidental. Every component had been over-engineered to survive battle damage that would cripple conventional aircraft. The wing spars could withstand loads 3 times the aircraft's maximum weight. The control cables were duplicated throughout the aircraft, with backup systems maintaining flight control even after primary systems were severed. The massive radial engine could continue operating with multiple cylinders destroyed, oil lines severed, and cooling fins shot away. Lieutenant Robert Johnson's famous survival of a devastating attack by German fighters illustrated this engineering philosophy in action. On June 26, 1944, Johnson's P-47 absorbed over 200 hits from cannon and machine gun fire during a prolonged attack by multiple German fighters. 20mm shells exploded throughout the aircraft. The canopy was shattered, hydraulic systems destroyed, engine cowling torn away, and control cables partially severed. Any other fighter would have been reduced to falling debris. Instead, Johnson flew his battered Thunderbolt back to England, landed safely, and walked away from an aircraft that looked like it had been fed through an industrial shredder. The survival of such massive damage sent psychological shockwaves through both air forces. German pilots began to question whether their weapons could actually destroy these American monsters. American pilots gained confidence that their aircraft would bring them home even from the worst combat situations. The armor protection philosophy extended beyond simple steel plating. The P-47's fuel system incorporated self-sealing tanks that automatically closed bullet holes to prevent fuel leaks and fires. The electrical systems were hardened against battle damage with multiple redundant circuits. Even the ammunition storage was designed to survive hits without exploding, using blast-resistant containers that channeled explosive forces away from critical aircraft structures. German intelligence services struggled to understand how American industry could produce such heavily protected aircraft in meaningful numbers. Traditional European thinking suggested that heavily armored fighters would be prohibitively expensive and slow to manufacture. The Germans discovered instead that American mass production techniques could build complex, heavily protected aircraft faster and cheaper than German factories could produce their lightweight interceptors. The Thunderbolt's gun installation represented another revolution in fighter armament. The 850 caliber machine guns were electrically heated to prevent freezing at high altitude, electrically charged to ensure reliable firing, and synchronized with precision that guaranteed all weapons fired simultaneously. The ammunition feed systems incorporated electric boost motors that prevented jamming during high G maneuvers. Each gun could be individually adjusted for convergence, creating precisely controlled firepower patterns that maximized hit probability. The psychological effect of this firepower on German pilots can't be overstated. Luftwaffe veterans who had survived years of combat against Soviet and British fighters described P-47 attacks as uniquely terrifying. The sound of 8 synchronized 50 caliber guns created a distinctive roar that could be heard miles away. German ground troops learned to recognize the approaching thunder that meant American fighters were inbound. The nickname Jabo Schreck, or fighter bomber terror, spread throughout German forces as the sound of approaching thunderbolts caused panic even among veteran troops. By August 1944, German fighter units were developing specific tactics to avoid engaging P-47s whenever possible. Unit commanders instructed pilots to attack only when they possessed overwhelming numerical superiority and favorable positioning. Even then, attacks were to be single high-speed passes with immediate disengagement. Prolonged combat with Thunderbolt formations was explicitly forbidden as suicidal. The strategic implications were becoming clear to German leadership. The Luftwaffe had lost air superiority not through inferior pilot training or inadequate numbers, but through technological obsolescence. German fighters optimized for the aerial warfare of 1940 were encountering American aircraft designed for the industrial warfare of 1944. The gap wasn't just in individual aircraft capability, but in fundamental design philosophy and manufacturing capacity. As autumn approached, the statistical evidence became overwhelming. P-47 units were achieving kill ratios of 4 or 5 to 1 against German fighters, while suffering the lowest loss rates of any Allied fighter. More significantly, damaged P-47s were returning to base and being repaired for continued operations while German aircraft losses were permanent. The mathematics of attrition warfare heavily favored the side that could build indestructible fighters faster than enemies could replace their losses. The revolution in fighter design was accelerating toward its inevitable conclusion. The crisis deepened with each passing week as German pilots discovered their most devastating attacks produced minimal results against American formations. Hauptmann Wilhelm Batz, commanding officer of Jagdgeschwader 52 and holder of the Knight's Cross with oak leaves, led what should have been a decisive interception against a formation of 16 P-47s escorting bombers near Stuttgart in September 1944. His unit possessed every advantage that Luftwaffe doctrine considered decisive: altitude superiority, numerical parity, experienced pilots, and the element of surprise. The attack began perfectly. Batz's Messerschmitt BF109s dove from 32,000 feet with the sun behind them, achieving speeds that made interception nearly impossible. The first pass should have scattered the American formation and left multiple thunderbolts falling toward the German countryside. Instead, Batz watched his pilots' cannon shells explode across P-47 fuselages that absorbed the punishment like armored battleships shrugging off rifle fire. The Americans didn't break formation, didn't panic, and didn't attempt desperate evasive maneuvers that would have left them vulnerable to follow-up attacks. What happened next violated every principle of aerial combat that German pilots had learned through 5 years of warfare. The P-47s turned into the attack, presenting their armoured fronts while their combined firepower created an impenetrable wall of destruction. Batz's wingman, attempting a second attack run, flew into the concentrated fire of 6 Thunderbolts simultaneously. The Messerschmitt didn't just crash or catch fire, it simply ceased to exist, transformed from a functioning aircraft into an expanding cloud of metallic debris in the span of a single heartbeat. The mathematical brutality of concentrated 50 caliber fire was becoming apparent to German survivors. Each P-47 could maintain continuous fire for 37 seconds, putting 3,200 rounds into the air during sustained bursts. A formation of 16 Thunderbolts generated over 51,000 rounds per minute during combat. No aircraft ever built could survive exposure to such concentrated firepower. Yet the Americans seemed to absorb German attacks without meaningful damage. Oberst Johannes Steinhoff, one of Germany's most successful fighter commanders with 176 victories, analysed combat reports from across the Western Front and reached disturbing conclusions. His assessment, classified top secret and distributed only to the highest levels of Luftwaffe command, revealed the scope of the crisis facing German fighter forces. American P-47 formations are demonstrating combat survivability that exceeds our weapons' capability to inflict decisive damage. Standard 20mm cannon fire, effective against all previous Allied fighters, produces minimal results against these heavily armoured aircraft. Prolonged engagements favour the Americans due to their superior ammunition capacity and damage tolerance. The industrial philosophy behind P-47 construction was fundamentally different from European approaches to fighter design. Where German engineers pursued elegant solutions that maximised performance while minimising weight and cost, American designers had created a brute force approach that prioritised survivability and firepower over refinement. The results were aircraft that seemed crude by European standards but possessed overwhelming practical advantages in actual combat. The engine installation exemplified this philosophy. The massive Pratt & Whitney R2800 was mounted in a framework that could absorb direct hits from 20mm cannon without affecting engine operation. The cowling incorporated armoured sections that deflected projectiles away from critical components. Even the propeller hub was armoured to prevent catastrophic failures from battle damage. German pilots discovered that direct hits on P-47 engines rarely resulted in immediate aircraft loss, while similar damage to German liquid-cooled engines meant certain death. Technical intelligence gathered from captured P-47s revealed construction standards that German engineers found difficult to comprehend. Individual components were built to tolerances that exceeded German precision manufacturing, while being produced in quantities that dwarfed European industrial capacity. The wing spars alone could withstand loads that would destroy entire German aircraft. The control systems incorporated redundancy that allowed continued flight operations even after primary systems were completely destroyed. Lieutenant Franz Stiegler, who would later become famous for his chivalrous treatment of a damaged B-17 bomber, encountered P-47s during escort missions over Bavaria in October 1944. His post-combat report captured the psychological impact these aircraft had on experienced German pilots. The American fighters demonstrate capabilities that challenge fundamental assumptions about aerial combat. They absorb damage that should be catastrophic while delivering firepower that makes evasion nearly impossible. Our tactical advantages in maneuverability and climb rate become irrelevant when the enemy can survive our attacks and respond with overwhelming force. The Republic P-47. Thunderbolt had accomplished something unprecedented in aviation history. German pilots who had dominated European skies since 1940 found themselves helpless against American fighters that redefined the possible. Armour that absorbed punishment, guns that created walls of destruction, and industrial capacity that made replacement faster than loss. The Luftwaffe discovered that aerial superiority belonged not to the most elegant aircraft, but to the most survivable. In the end, German cannon fire couldn't break what American engineering had made unbreakable.